This is Christopher Sernaque, hosting episode 2 of season 1 of the Current Topics in Science podcast. This podcast will address breaking scientific news in light of the origins debate and host interviews with scientists. This podcast is available on the following platforms: iTunes, Stitcher, Google Podcast, Spotify, and iHeartRadio. Video recordings of this podcast will be uploaded to YouTube. Enjoy the podcast. "18 months ago, NASA's Parker Solar Probe was sent on what has been called a historic sun-kissing mission. As a follow-up, NASA and ESA are launching a brand new solar mission this February. According to the International Business Times, the mission, known as Solar Orbiter, features a 4,000-pound spacecraft that's equipped with various scientific instruments. It is scheduled to launch on February 5th through an Atlas V rocket on the Cape Canaveral Air Force Station. The Parker Solar Probe, the one that was sent on the sun-kissing mission, was able to get extremely close to the sun. The International Business Times reports that the Parker Solar Probe was able to approach the sun from a close distance of 15 million miles, end quote. The Parker Solar Probe is intending to get a distance of about 3.8 million miles from the sun. The Solar Orbiter's intended mission is to capture images of the sun's poles. Just like the Earth, the sun also has poles, and scientists intend to study the magnetic field of the sun based off of data gathered from these images. The historic launch of the Solar Orbiter is currently set to occur on the 5th of February of the year 2020. The launch base is at the Cape Canaveral Air Force Station in Florida. Scientists are extremely excited about this great opportunity for research. Holly Gilbert is the NASA Deputy Project Scientist for Solar Orbiter. Last month, she attended the yearly autumn meeting of the American Geophysical Union, or AGU, in San Francisco. Holly Gilbert said we have every reason to be excited about the Solar Orbiter because, in her words, we've never been able to image the poles of the sun. That is extremely important for helioseismology, but also for looking at the global magnetic field of the sun. In order to model space weather, activity, and activity in general on the sun, we need that full global picture of the magnetic field, end quote. According to ESA, the Solar Orbiter weighs approximately close to 4,000 pounds and is equipped with 10 different scientific instruments. ESA says that these instruments will be utilized to examine how the sun creates and controls the heliosphere, the vast bubble of charged particles blown by the solar wind into the interstellar medium, end quote. Mark Unveil of the University of California, Los Angeles, is the observatory scientist for the Parker Solar Probe. He summarized the hope of the joint mission of the Parker Solar Probe and Solar Orbiter better than I can. You can almost hear the joy and curiosity in his voice as he says, "Magnetism is fundamental to all of astrophysics and the universe itself. And therefore I think we can safely say that with the accomplishment of these two missions, our understanding of what's called the basic astrophysical plasma of the solar system and the universe will have changed entirely." While the mission of the Parker Solar Probe and Solar Orbiter are going to reveal brand new, fascinating facets of information about the sun, there is still a paradox about the sun that has not been solved. This paradox is called the faint young sun paradox. Before we explore the paradox, we have to first find out what a main sequence star is. According to astronomer Dr. Danny Faulkner, assuming that thermonuclear fusion is powering the sun could shine for a very long time because thermonuclear fusion is such an efficient source of energy. Calculation shows that it is capable of supplying the sun's current luminosity for about 10 billion years. It is believed that most stars are powered by the same sort of nuclear reactions in their cores, a situation that is referred to as the main sequence. The main sequence is thought to be a period of stability which represents the greatest portion of a star's long life. End quote. Now, astronomers believe that the sun has been a main sequence star since it formed, at the time they place to be about 4.6 billion years ago. Astronomers give main sequence stars a lifespan of about 10 billion years. So if the sun is 4.6 billion years in age, it has used approximately half of its store of energy. The hydrogen in the core of the sun, as time goes on, is converting into helium. As stated, since astronomers estimate the sun to be about 4.6 billion years in age, about half of the hydrogen in the core of the sun is now helium. This is not without consequence. The conversion from hydrogen to helium occurs by a process called nuclear fusion, which increases the mean molecular weight. The increase of the mean molecular weight compresses the increasing fusion rate of the core of the sun. This effect would produce a sun, according to Dr. Faulkner, that should be nearly 40% brighter than it was 4.6 billion years ago. End quote. If this is the case, then Earth was significantly colder in the past. This poses a problem for the evolutionary theory because the temperature of the Earth would have been below freezing 3.5 billion years ago, which is when life was supposedly evolving. As the core temperature of the sun's core increases, the energy output of the sun would also increase, which, as stated, would cause the sun to brighten over time. In other words, an early sun would have been fainter, warming the Earth 31 degrees Fahrenheit or 17 degrees Celsius less than it does today. The temperature is below freezing. This is a problem for the evolutionary theory, which has been dubbed the faint young sun paradox. While the faint young sun is a paradox for the evolutionary theory, it is not a problem for the young Earth creation model. Young Earth creationism is the idea that God created the Earth in 6 literal days and rested on the 7th, and that the Earth is roughly 6,000 years in age. This 6,000-year time period is determined by the fact that there are about 2,000 years from Adam to Abraham, 2,000 years from Abraham to Christ, and 2,000 years from the time of Christ to our day. The young Earth creation model would predict that the Earth was created about 6,000 years ago, along with the sun. Therefore, the sun's luminosity would never have been a problem. In today's episode of Current Topics in Science, we learned that the solar orbiter is going to reveal new information about our sun, and the faint young sun paradox is resolved by taking God at His word. Thank you very much for taking the time to learn with us on Current Topics in Science, where scientific discoveries are examined in light of the origins issue. Please share and subscribe to the Current Topics in Science podcast. It is available on iTunes, Stitcher, Google Podcast, Spotify, and iHeartRadio. Thanks again for listening, and remember, the truth saves.